So this is the review of St. Beats question paper. First question, a unit charge moves on an equipotential surface. What is VA minus VB? Equipotential surface, the potentials will all be equal. So option is VA minus VB is equal to 0. Second question, the electric potential varies with X, where V is equal to 5 plus 4X square. Whenever they ask you electric field, you should differentiate it with minus dV by dr to be the differentiation. So minus 8x is the electric field's formula, which is Newton per Coulomb. And then to find the electric force, E is equal to FQ, F is equal to E into Q. You know what is the electric field at a distance 0.5 is the question. They've mentioned the meters to be 0.5 meters. Into the charge, so the force experienced by a negative charge of 2 × 10 to the power minus 6 located at distance x is equal to 0.5. Just do this and you get the option. So let's go to next question. Is the third question. 4 points A, B, C, D are set at equal distance from a dipole like this. So the options given in the school paper is completely wrong. We all know that VD and VB are equipotential surface, and so equatorial line of a dipole. So the potential will be 0. So VB is equal to VD. But A and C are the points on the axial line, and they has to be again equal. But such an option is not given in the question paper. So therefore, the teacher should give marks for this options being incorrect in St. Beats. Let's go to fourth question. Choose the wrong statement. The electric potential is parallel to the electric field is parallel to the equipotential surface is the wrong answer. So then fourth one is the wrong option. Is B. So electric field is always normal to the equipotential surface. Okay, now so let's go to fifth one. The graph D is the right answer. In fact, the given graph also is incorrect. To be very honest, EBR graph, I've told you, mark this as half. When you do electric field, E is equal to 1 by 4 pi epsilon Q by half the whole square. 4 will go up. Electric field will be up. Potential will be down for half. And for R, at 1, electric field and potential will be at the same point. But after it crosses 1, the voltage will come up and the potential will go. Potential will go up and the electric field will go down. The graph has to be like this. Has to be like this and like this. And for the potential, it has to be like this and like this. Ideally, this is at one point you should compare. That is not given in any of the graphs. They're all rough graphs. Anyway, D is the right answer. So let's go to next question. The next question is name the physical quantity which is said it is joule per coulomb. No. I've left many questions, right? What is this option? Fifth question is done. Name the physical quantity. Joule per coulomb is nothing but V is equal to W by Q, so volt. So that's the right answer. So next is a scalar, and a relation between electric field and potential E is equal to minus dV by dr. Next is find the equipotential, draw the equipotential surface. Note that if you're doing it for negative, the electric field lines terminating in negative. So make sure that you're drawing the lines far away as closer, the one nearby as a little away from each other. This is the diagram. But when it comes to positive charge, it will be closer, nearer. And as you move away, it should be farther. Okay, this difference I have not explained in the class. Hope you get it clear now. So then the uniform electric field has to be drawn like this. And equipotential surface is the red color lines, red color planes. Eighth question. The potential at B and C are the same. So it's enough if you find the potential difference between A and B. VA, VB is enough. So let's find the distance AB. Hypotenuse square minus height square. So you get it as 4. So you know the distance between A and B. You know the electric field's value. So the formula is V is equal to E into D. You get the right answer. Ninth question. Write an expression for the potential at distance R from any charge Q. This derivation is what they're asking. And so next is 10th question. Calculate the potential in a point P due to a source charge located 9 cm away. So then therefore it's 1 by 4 pi epsilon Q by R. Just calculate and leave the answer. Let's go to next question. Find the work done in moving charge 2 × 10 to the power minus 9 coulomb. So the potential at that point, the charge that you're going to bring, multiply and get the work done and write the answer in joules. The answer does not depend on the path taken since electrostatic force is conservative. It is not going to depend on any path. So let's go to section C. Section C is what I'm doing now, sorry. So next is 11th question. You have two charges located 15 centimeter apart. Where will the potential be 0? It can be at the middle also. It can be outside the negative charge. The outside the negative charge you may not have written. That's something you need to note down. That's very, very important. Let's go to next question. Derive an expression for electric potential at any point. Yes, that I've written. Then calculate the electric potential at the center of the square also I've done. So this is what you should have done. And this is the answer. The potential is means you have to take positives as positive, negative as negative. You have to find half the diagonal to know the distance at the center from the charged particle. And this is the answer. And that's the case over. Such a simple paper.